Dear students, let us start Module 2 from Transformers and Generators subject. So the Module 2, it is having the topics like different testing methods of transformers, that is tests, parallel operation of transformers, auto transformers and tap changing transformers. So here first we will see what are the different testing methods like polarity test, Sumpner test. Then comes uh, parallel operation of transformers. So how to connect the transformers in parallel when they are having separate equal kVA rating or unequal kVA rating. That is the concept we are going to study in parallel operation of transformers. Then comes single winding transformer, which we call it as auto transformer. Then tap changing transformers. Right. So now in this class we will discuss for testing methods of transformers. So in the testing method, we are having the test like polarity test and Sumpner test. Polarity test and Sumpner test. Now, first we will discuss with Sumpner test, which is an important concept. So already we have studied OC and SC test, right? So open circuit and short circuit test, they are going to give the information of performance characteristics of transformer like efficiency and voltage regulation, right? So already we are having OC and SC test with us to determine efficiency and voltage regulation of transformer, but still we are going to prefer or use Sumpner test due to some reason, right? So why we are using that Sumpner test and what is the advantage of using Sumpner test for determining efficiency and regulation apart from OC and SC test, that we will discuss now. Right. So today we will discuss for Sumpner test. So the other name for the Sumpner test is back-to-back test. It is called as back-to-back test. Means here we are using two transformers. Both transformers, they are connected parallelly, and one transformer will act as a load on the other transformer. Because of that reason, we call this test as back-to-back test. Okay. Now let us see the description here. Sumpner's test is another method of determining efficiency, regulation, and heating under loading conditions. So this is also the other method to determine efficiency, regulation, and heating under loading conditions. Next, the OC and SC test gives us the equivalent circuit parameters, but cannot give heating information under various loading conditions. Already we have seen that OC and SC test, they are going to give us the information of equivalent circuit parameters like R naught, X naught, I naught, IC, IM, R1E, X1E, Z1E, all those parameters which are related to equivalent circuit parameters information, we can get it from OC and SC test, but it cannot give the information of heating information. Heating information means rise in the temperature. Okay, heating information under various loading conditions, because there we are going to, in OC and SC test, we are going to assume some pre-loading conditions. So for that particular loading condition, what will be the rise in temperature, that is unknown to us. So it cannot be possible for us to determine what is the rise in temperature in OC and SC test for different loading conditions. Okay. Sumpner's test gives heating information also. So the advantage of Sumpner test is, apart from giving OC and along with the information of efficiency and regulation, those values, they are going to be accurate. Why? Because efficiency and regulation values whatever we are calculating using Sumpner test, it will be taken into account for heating information also. Since heat information is added in the efficiency and regulation values, so accurate values of efficiency and regulation we are going to get from Sumpner test. Whereas in OC and SC test, heating information is absent. So because of that absence of heating information, whatever values of efficiency and voltage regulation we are calculating, that they are not accurate. They are not accurate because their heating information is not added into that. Now, in OC test, there is no load on the transformer, while in SC test also only fractional load gets applied. So in open circuit, it is almost no load. So their rise in temperature is less, whereas sorry, it is almost very nil. Whereas in short circuit test, we are going to apply only fraction of the full load. Because of that, load is also not getting applied that much. Okay. In OC and SC test, the loading conditions are absent. So almost all we can say that loading conditions are absent. Hence the results are inaccurate. Means that loading condition are absent in the sense, if we add load, if we connect some load, then current will start to flow in the secondary winding. That is, current I2 will start to flow. If current I2 will start to flow, means copper loss will come into picture. Copper loss means copper losses in the winding, that is I2 square R2, I1 square R1. Right, I2 square R2 means copper losses on the secondary side. If copper losses will come into picture, means there is a I square R loss is nothing but what? Physical, it is nothing but a heat. So that heat information, it is not added if it is OC and SC test. But now here one transformer is acting as a load on the other transformer, that is back-to-back test. Because of that loading condition, we can get actual rise in temperature value. That actual rise in temperature value will be giving us exact values of efficiency and voltage regulation in Sumpner test. Okay. In Sumpner test, actual loading conditions are simulated, hence the results obtained are much more accurate. Here we are actually loading the transformer. Actually loading the transformer in the sense, when two transformers, they are connected in parallel. This is the diagram you can see. So this is the circuit diagram for your Sumpner test. This is transformer 1 T1. This is transformer 2 T2. So both these transformers connection, they will be connected in parallel. So primary of both the transformer T1 and T2, they are connected in parallel, and whereas T1 and T2 transformer secondaries, they are connected in series opposition. They are connected in series opposition, and the condition for this Sumpner test is that both transformers, T1 and T2, both transformers T1 and T2, they should be identical. Identical means of same kVA rating. Similar rating transformers we should make use of. Okay, and see that first transformer will act as a load on the second transformer. Similarly, second transformer will act as a load on the first transformer. So the transformer itself is acting as a load on the transformer. Because of that, actual loading conditions we can observe and we can simulate in the Sumpner test. If actual loading is present, then current, it will be flowing through the secondaries of both the transformers. Because of that, copper losses I1 square R1, I2 square R2 will come into picture, and copper losses is nothing but rise in temperature. That rise in temperature or heat, that information will be given by the wattmeter W2. Wattmeter W2 will read copper loss information. So rise in temperature value will be added, and it will be given with the help of this wattmeter W2. Because of that, whatever efficiency and regulation values we are calculating, they are accurate in comparison to the OC and SC test. In OC and SC test, heating information is absent because it is as good as no load condition. If no load means there is no current flowing in the secondaries. If current is not flowing in the secondaries, then there is no copper loss, much copper loss. If there is no much copper loss, then there is no rise in temperature. Heating information will be absent. Due to that, actual or accurate values of efficiency and regulation, we cannot find it in OC and SC test. Right. Now, in Sumpner's test, actual loading conditions are simulated, hence the results obtained are much more accurate. Thus, Sumpner's test is much improved method of predetermining regulation, that is voltage regulation and efficiency, than open circuit OC and short circuit test AC. So it is an improved version of OC and SC test, what you can say. So here we are going to get exact values of efficiency and regulation in comparison with the OC and SC test, because in OC and SC test, actual loading condition is absent, whereas here loading condition is present. Loading means Here one transformer will act as a load on the other. Because of that, loading condition will be there. Because of that, current I2 will flow. Because of that, copper losses I2 square R2 will appear. Because of that copper loss, there is a rise in temperature, and that rise in temperature value will be given to us by the wattmeter W2. Wattmeter W2. This wattmeter W2 will read heating information. Right. Now, the Sumpner test requires two identical transformers. So Sumpner test, it requires two identical. Identical means both transformers T1 and T2, they should be of similar kVA rating. They should be of similar kVA rating. If this is 5 kVA transformer, if T1 is 5 kVA transformer, means secondary, sorry, T2 transformer should also be 5 kVA only. That is the meaning. That is called as similar transformer or identical transformer. The Sumpner test requires two identical transformers. Both the transformers are connected to the supply. Both the transformers are connected to the supply such that one transformer is loaded on the other. As I told you, here there are two identical transformers T1 and T2. So for T1 transformer, T2 will act as a load. Similarly, for T2 transformer, T1 will act as a load. So actual loading condition we can observe in the Sumpner test. That is the meaning. Both transformers are connected to the supply such that one transformer is loaded on the other. Thus, power taken from the supply is that much necessary for supplying the losses of both the transformers, and there is very small loss in the control circuit. So power taken from the supply is that much necessary for supplying the losses. So here you can see that transformer T1 primary, transformer T2 primary, both they are connected to the power supply. So these are the two power supply lines. These are the two power supply AC lines. So T1 transformer primary winding, T2 transformer primary winding, both they are connected across the AC lines, AC power lines, and that too primaries they are connected in parallel fashion. They are connected in parallel fashion. Then, yeah, and whatever power it is, these two transformers they are taking from the power supply means they are just sufficient to meet out the losses. Meet out the losses means iron loss and copper loss, and very less amount of the power will be taken by these what is that controlling circuits. Controlling circuits means all wattmeters and all. Thus, power taken from the supply is that much necessary for supplying the losses of both the transformers, and there is very small loss in the control circuit. Then, while conducting this test, the primaries of the two identical transformers are connected in parallel across the supply V1. So as I told you, this is the AC lines, and the voltage across these two AC lines is V1, and this voltage is measured by the voltmeter V1. Okay, this is AC supply 1. It is measured with the help of voltmeter, which is connected across the AC lines. And both the transformers primary, T1 transformer primary, T2 transformer primary, they are connected in parallel to the AC lines. And voltage across the AC lines is measured with the help of voltmeter V1. V1 is the input AC voltage. Input AC voltage that is measured with the help of voltmeter V1 across the AC lines. While the secondaries are connected in series opposition. Try to understand here. While the secondaries are connected in series opposition, so that induced EMF in the two secondaries oppose each other. Right. The secondaries are supplied from another low voltage supply and are connected in each circuit to get the readings. The connection diagram is as shown in the figure 1. So you can see here, this is a circuit diagram for Sumpner test where we are using two identical or similar rating transformer T1 and T2. Primary of transformer T1 and primary of transformer T2, both they are connected in parallel across the AC lines, and voltage across the AC line is V1. Right, this is the primary side circuit. And apart from these connections, secondaries, if we see here, secondary of transformer T1 and secondary of transformer T2, they are connected in series opposition. Series opposition means here suppose if the voltage induced in the first T1 transformer on the secondary side, here if it is 230, and on the second transformer secondary T2 is also 230. Series opposition means what? The voltage induced in first transformer, that is voltage across EEF and EGH, they both should be equal and opposite. If it is 230, this should also be 230, and in series opposition connection, one voltage will oppose to the other. One voltage will oppose to the other means 230 minus 230, net voltage will be 0. Net voltage will be 0. If it is double voltage, then you cannot close the switch. So before conducting the test, the secondaries of the two transformers, they should be connected in series opposition. They should be connected in series opposition such that voltage induced in the first transformer secondary side, similarly voltage induced in the second transformer secondary side, both should be equal and opposite, such that net voltage is 0, so that there is no loop current will flow in this loop. There is no current will flowing in the loop. And apart from this, we are using two wattmeters here. So this is wattmeter W1, which is connected across the AC lines, and this is the wattmeter W2, which is connected on the secondary of the transformers. So here W1 reads copper iron loss, that is constant loss. W1 reads iron loss or constant loss, whereas W2 will read copper loss or variable losses. And before conducting the test, this switch S should be kept open. We should not close this switch. So switch S should be kept open, and the secondary of the two transformers which are connected in the series opposition, they are excited with other low voltage electrical device. So here secondaries, once again they will be excited from the other side with the help of another regulating transformer which is of low voltage. This is just to simulate or to conduct short circuit test, and whereas on this side here we are conducting open circuit test. This is for open circuit test and this is for short circuit test, which is, if we compare it to OC and SC test, this side this wattmeter will give us open circuit information, that is iron loss. This side it is for short circuit test, and this wattmeter W2 will give us short circuit information, that is copper loss. Right, now T1 and T2 are two identical transformers. T1 and T2 are two identical transformers. The secondaries of T1 and T2 are connected in series opposition. So secondaries, they are connected in series opposition. So EEF is equal to EGH. It means that voltage at this first transformer secondary side EEF is equal to secondary side of second transformer T2, that is EGH. Both should be equal and both should be opposing to each other. So equal and opposite means 230 minus 230, if it is single phase means net voltage will be 0. That is the meaning. So EF is equal to EGH, that is induced in two secondaries are equal, but the secondaries are connected, such that E is connected to G. So secondaries, how they are connected, let us see here. So to get the series opposition connection on the secondary side, how it should be connected, let us see there. In the let us see here. You can see here. So EEF is equal to EGH, that is induced in two secondaries are equal, but the secondaries are connected such that E is connected to G. You can see the connection here. E is connected to G. G means what? This is first point of secondary side of second transformer, that is T2. E is connected to G, then H is connected back to F via some ammeter, wattmeter switch. So E is connected to, you can see here, you can see the flow. E is connected to G, then H is connected back to F via the some regulating transformer terminals, ammeter E2, wattmeter W2 and switch. That is the meaning. Due to such series opposition, two EMFs acts in opposite direction to each other and cancel each other. So because of this connection, that is E is connected to G and H is connected back to F, because of such connection, here we can see that both voltages will be equal and opposite to each other. If it is EF is 230 and EGH is 230, 230 minus 230 will be 0 and no currents will flow in the loop here. That is the meaning. Okay. So net voltage in the local circuit of the secondaries is 0. So the net voltage is 0. So no current will flow through the loop here. And primaries are excited by supply 1. Now these are some precautions what you have to take before conducting the experiment, and this experiment is your part of your syllabus in the laboratory. Okay, now you can see here, so net voltage in the local circuit of secondaries is 0. Now how to conduct the test? So the procedure for conducting this test is, it is similar to the OC and SC test. Okay, and primaries are excited by supply 1 of rated voltage. I told you that this part of the circuit is for open circuit test and this part of the circuit is for short circuit test, right? So in open circuit and short circuit test we are conducting the two tests separately, but here in the Sumpner test, once again here we are conducting same kind of OC and SC test, but simultaneously parallelly we are conducting both OC and SC tests. So this much portion will be for OC test and this much portion will be for SC test. So if it is open circuit on this side, means this will read wattmeter W1 will read iron loss, ammeter A1 will read no load current I0. So this will give us I0, this will give us W0, and this will be our V0, V0, I0, W0. So this will be our open circuit test parameters. Similarly, on the secondary side, this will be our short circuit test condition, and meters here will give us the information. W2 will give us short circuit power, that is WSC. This is copper loss, and this is A2. A2 will read short circuit current ISC, and V2 will read the information of VSC, short circuit voltage. So here, in one single setup, we can conduct both open circuit test and short circuit test simultaneously, which is not possible in normal open OC and SC test. Right. So first, when primaries are excited by supply 1 of rated voltage. So here, primaries means this, the first primary of T1 and first primary of T2. These two are connected to power supply lines and they will be excited with what? Rated voltage, because if it is open circuit means always in the open circuit the condition is we should apply rated voltage. So first, keeping the switch yes open, apply rated voltage. Apply rated voltage after doing all the connections like this, keeping switch yes open with secondaries in series opposition. Now apply voltage on the primary side. Primary side means primary of T1 and primary of T2 which are connected in parallel. Apply the rated voltage. Apply the rated voltage. And primaries are excited by supply 1 of rated voltage and frequency. So there is no current flowing in the loop formed by the two secondaries. So here you can see that keeping the switch yes open, we are applying rated voltage. So at that period of time, here there is no current flowing in the secondary. So it is as good as open circuit test. It is as good as open circuit test. And when we apply the rated voltage, let us see what will happen now. This series opposition can be checked by the another voltmeter connected in the secondary circuit as per the polarity test. So there is another method to check whether voltage is 0 or not. So here, as I told you, we should connect the secondaries in series opposition. Series opposition is, if here it is 230 and here also if it is 230, 230 minus 230 net is difference will be 0. Whether this difference is 0 or not, to check that one, here we are connecting one voltmeter across the switch. Here we are connecting one voltmeter across the switch, and if this voltmeter will read 0, then only we should close the switch. Otherwise, if it is not 0 means that will be additive polarity. Additive polarity means instead of 230 minus 230, it will be double voltage. That will be 230 plus 230, which is 460, which is a danger voltage or harmful voltage, which we should not allow to flow through this circuit. So before conducting the short circuit test, first we should keep the switch open. So first we should apply rated voltage, then we should When once rated voltage is applied, then no current will flow through the secondaries as switches is opened. After switch, yes, since it is open, then we should check the voltage across the switch. Here voltmeter is not shown, but here we are connecting one voltmeter across the switch. Once that voltmeter reads 0 means then it is safe and connections are correct. It means that the secondaries are connected in series opposition. That is the meaning. Now, if it reads 0, the secondaries are in series opposition, and if it reads double the induced EMF in each secondary, it is necessary to reverse the connection of one of the secondaries. So, suppose if it is not 0, if it is double, 230 plus 230, if it is 460, then we should interchange any one of the connection on the secondary side. And once again, we should check the polarity. If it is 0, then it is well and good. If it is not 0, then we should interchange any one of the connection of the secondary, only one. After interchanging, then once again you should check. If it is 0, then our connections are correct. It means that both the secondaries are in series opposition. Okay. Now, as per superposition theorem, if V2 is assumed 0, V2 means, you can see here, V2 means this is the second voltmeter V2, which is on the secondaries of the other transformers. So secondaries of the other transformer means this will give simulate for short circuit test. If short circuit test side voltmeter V2 is assumed to be 0 as per superposition theorem, then what will happen? You can see here. As per superposition theorem, if V2 is assumed 0, then due to phase opposition, so current flows through secondary, and both the transformer T1 and T2 are as good as on no load. So if voltage is V2 is 0, if as per superposition theorem, if voltage V2 is assumed to be 0, and because of the series opposition connection, there will be no current flowing in the secondaries. If no current is flowing through the secondaries, means it is as good as only no load test. No load test means open circuit test on the primary circuit side, because here switch is open, voltage V2 is assumed to be 0. Since voltage is V2 is assumed to be 0, and already these are in series opposition, secondaries are in series opposition, means no current will flow through secondaries and current will flow only through the primary. Only through the primary means current I1 will flow. And how that current I1 will flow means this current is pertaining to only primary side. Primary side means open circuit test. Open circuit test means here we have applied rated voltage. So this will give us no load current I0, no load voltage V0, and no load power, that is iron loss, that is W0. So W1 will read W0, E1 will read I0, E1 will read V0. So all these are open circuit test parameters. Let us see that. So OCU test gets simulated. The current drawn from the V1 in each case is 2 times of I0, where I0 is no load current of each transformer. The input power measured by the wattmeter W1 thus reads the iron loss of both the transformers. So now here you can see that for both these two transformers, which are connected in parallel, there is one single wattmeter and there is one single ammeter. So this ammeter E1 will reads no load current I0 of two transformers. No load current I0 of two transformers, that too they are identical. So here in this case, A1 reads 2 times of I0, 2 times of no load current. Similarly, this W1 reads total iron loss of both the transformers. That is W1 is equal to 2 times of Pi. If Pi is iron loss of individual transformer, Pi plus Pi, that is iron loss of first transformer and iron loss of second transformer, which is of similar reading, then W1 is equal to 2 times of Pi, whereas A1 is equal to 2 times of I0. That is, this will read 2 times of no load current. This will read 2 times of iron loss, because why 2 means here we are using two identical transformers. Both transformers iron loss will be read by W1. So W1 is equal to 2 times of Pi, and ammeter A1 will read E1 is equal to 2 times of no load current I0. That is the meaning. Then the input power as measured by W1 thus reads the iron loss of both the transformers. Then Pi means iron loss. Iron loss per transformer is equal to W1 by 2, as T1 and T2 are identical. So here, if I want to know what is the iron loss of T1 and what is the iron loss of T2, since both are of similar kVA rating, then make it half. Whatever W1 we have got, W1 suppose if it is 50 watt, then 50 by 2. So 25 watt will be the iron loss of T1 transformer. Remaining 25 watt will be the iron loss of second transformer. So W1 by 2 will give iron loss of each transformer. That is the meaning. Then. So now here we have conducted open circuit test. Then how to conduct short circuit test, that one you can see here. Then a small voltage V2 is injected into the secondary with the help of low voltage transformer by closing the switch. So after conducting open circuit test, then we should go for the short circuit test. So before conducting short circuit test, we should check the voltage across the switch here. Here we are connecting one voltmeter. So we should check that voltmeter whether it side, and once again we should check the voltage across the switch. If it is 0, then it is well and good. Otherwise we should once again change the connection. If it is 0, then voltage is 0, which is observed across this voltmeter, then we should close the switch now. After closing the switch, what will happen? Current will start to flow from this end, and here we are connecting one low voltage regulating transformer. Low voltage means always we know that for short circuit test the condition is we should apply rated current. We should apply rated current, but to get that rated current only small amount of voltage is sufficient enough, which is only small amount of voltage is sufficient enough. So our short circuit test is a reduced voltage test where small amount of voltage is sufficient enough to allow rated current to the secondaries of the two transformers. So here in this case, after closing the switch, we should conduct short circuit test. For that sake, we are using one low voltage regulating transformer, on the secondaries of the two transformers. Then a small voltage V2 is injected into the secondary with the help of low voltage transformer by closing the switch S. With the regulation mechanism, the voltage V2 is adjusted so that rated current I2 flows through the secondaries as shown. Okay. Now, once voltage is 0, then close the switch. Then we should apply very small amount of the voltage, and very small amount of the voltage such that the two transformers should carry rated current. So that rated current information will be observed with the help of ammeter A2. So ammeter A2 is short circuit current, and that can be observed on this ammeter A2. So to get the rated current via this through this ammeter A2, very small amount of voltage is sufficient, and that small amount of voltage is V2. It can be measured or observed on the V2. Okay. Once rated current is we have obtained, then we should not change the voltage, because even a small change in the voltage may allow transformer to carry huge load. Huge load means huge current. Current is proportional to the load. So once we get rated current, and then we should not apply further voltage. That is the meaning. With regulation mechanism, the voltage V2 is adjusted so that the rated current I2 flows through the secondaries as shown. Now, I2 flows from E to F, then from H to G. So you can see that current I2 means the current that is flowing through the secondary side. So the current that is flowing is from E to F, then from H to G. So the flow of the current after closing the switch and after applying small voltage and allowing rated current to flow through the ammeter A2, that is short circuit current, that circuit current I2 that will be flowing from the path point from point E to point F, that is secondary of T1 transformer. Then it will flow from from point H to G. So it will follow the path E, F, H, G. In this way it will flow. Okay. Then I2 flows from E to F and then from H to G. The flow of current I1 is restricted to the loop BAIJCDLKB, and it does not pass through W1. So it means that current I2 will follow the path EFHG, that is short circuit current. Then similarly, current I1 which is flowing on the primary side. Primary side means this is open circuit. So current I1, primary current I1 will follow the path B A B A I J C D L A back to point B. So the primary current I1 will follow the path point B A I J C D L A back to B. Okay, and this will not flow through the other meters. So I1 will flow. I1 will not flow through the other meters. So now you can see that PAI and it does not pass through the pass through W1. So W1 means what? W1 means the wattmeter which is reading iron loss. So current I1 will flow only through this path only. It will not flow through this path. It means that W1 will read no load. W1 will read iron loss and A1 will read 2 times of no load current I0. But whereas this is primary current I1. I1 will follow the path VAI JCD JCD LKB. It will follow only this path only. This current will not enter to the wattmeter W1 and ammeter A1, which are related to iron, which are related to the open circuit test. So this will I1 will follow only this path, and secondary current will flow from E, F, H, and G. That is the meaning. Hence, W1 continues to read core losses. So, since primary current it is flowing only in this path, that is point B, A, I, J, C, D, L, K, B. So, this current will not flow through that W1. So, W1 will continuously read iron loss, whereas W2 will continuously read copper loss. A1 will read no load current, B1 no load voltage. A2 reads short circuit current, that is ISC. V2 will read short circuit voltage, V2. So this is as good as our open circuit and short circuit test, but the only difference is here the transformers will be acting as a load. First transformer will act as a load on the other. Because of that, heating information will be included. Because of that, accurate results of efficiency and regulation we are getting. Now, hence W1 continues to read core losses. Both primaries and secondaries carry rated current. Right, both primaries and secondaries. Both primaries and secondaries carries, both primary of T1 and T2, secondaries will carry what? They will carry the rated currents. Since the condition required for short circuit test is rated current. So primaries of both transformer T1, T2, secondaries of both transformer T1 and T2, both they will carry rated current. So in that case, it is as good as short circuit test is conducted. That is the meaning. Both primaries and secondaries carry rated current, so short circuit test conditions gets simulated or conducted. Thus, the wattmeter W2 reads the total full load copper loss of both the transformer. Like I told you, W2, if it is carrying rated current on this side, then this will give us full load copper loss of both the transformers W2. Similarly, W1 will give us full load iron loss of both the transformers. Now, PCU FL transformer. Since this wattmeter will be giving us full load copper loss of both the transformers, but if we want full load copper loss of individual transformer, then W2 by 2. W2 by 2 we should do. It means that if 100 watt we are getting in this through this wattmeter, then 100 by 2, 50 watt will be the full load copper loss of T1 transformer, remaining 50 watt will be the full load copper loss of transformer T2. That is the meaning. Now, thus the wattmeter W2 reads the full load copper loss of both the transformers. That is PCU FL is equal to PCU, that is copper loss full load FL per transformer is equal to W2 by 2. Right. Now, the key point here is, thus in the Sumpner's test, without supplying the load, full load iron loss occurs in the core, while full load copper loss occurs in the winding simultaneously. So here, without connecting, supplying the load, without supplying, you may ask the question, so where is the load? But here, the load itself is the transformer. This transformer T1 will be acting as a load on the second transformer T2. T2 will act as a load on the first transformer because they are connected back to back. If you check this connection, one transformer will act as a load on the other. So here, loading, even though we will say that here load is not there, but transformer T1 will act as a load on to T2 and T2 will act as a load on T1. So loading conditions are satisfied here. Because of that, it will give exact copper loss information. Exact copper loss information means W2 wattmeter, which will give us copper loss information, and that W2 will include all the heating information. Because of that, once we make use of all these values in our calculation of efficiency and regulation, then those values will be accurate in comparison to the OC and SC test. So here, open circuit test as well as short circuit test. Open circuit test means on this side, open circuit test on this side, short circuit test on this side. It will both it will be conducted simultaneously. Both it will be conducted simultaneously. That is the meaning. Thus, in the Sumpner test, without supplying the load, full load iron loss occurs in the core. Core means in the core part, it will iron loss will occur in the core, while full load copper loss occurs in the windings simultaneously. Hence, heat run test can be conducted on the two transformers. So here, heat run test is possible on both the transformers. Whereas in OC and SC test, both the losses do not occur simultaneously. Yes or no? In OC and SC test, in both the tests they are conducted separately. Because of that, we cannot get the information of heat run test. This is the advantage of Sumpner test. So here both OC and SC test we are conducting simultaneously, and that too one transformer will act as a load onto the other. Because of that, we call it as back-to-back test. Because of the loading condition, heat run test is possible. Because of the heat run test, we are getting accurate results of efficiency and regulation, and that too here open circuit OC and short circuit test SC will be conducted simultaneously. So these are all the advantages of Sumpner test, and these advantages are not possible in the normal open circuit and short circuit test, because there we are conducting OC and SC test separately, and there we are not conducting any load. We are not sorry we are there we are not connecting any load in normal OC and SC test. But here Sumpner test, it is the form of OC and SC test only. Both OC and SC test will be conducted simultaneously, and that too loading condition is also present. Since loading condition is present, because of that heat run test is possible. Because of that iron copper loss will come into picture. Because of that copper loss means physically it is actually nothing but heat. That heat information will be included. Heat information means copper loss, and that copper loss information will be given by the wattmeter W2. Wattmeter W2. Okay. So this is the advantage of Sumpner test. So Sumpner test gives us accurate results of efficiency and regulation. So finally, what is the formula to calculate efficiency? From the test results, the full load efficiency of each transformer can be calculated as, because here in the Sumpner test we are using two transformers which are identical. Identical means similar with kVA rating. So if I want to calculate efficiency percentage eta full load of each transformer, then formula input into 100. Output is as it is. Input is output plus total losses. Total losses means iron loss, that is W1, plus copper loss W2. But here we want to calculate for each transformer. But we know that W1 is the iron loss of both the transformers. Similarly, W2 is the copper loss of both the transformer. So for each transformer, make it half, W1 by 2 plus W2 by 2. So make it half, then that will give us the information of efficiency of each transformer, where this output is nothing but kVA cos phi, where output is nothing but kVA. K means VA rating multiplied by cos by 2. Right. Then the key point here is, as all the voltage, currents and powers are measured during the test, the equivalent circuit parameters can also be determined. So here we are getting the information of all the voltages, currents and power, that is W1 and W2. So using the same result, Sumpner test, we can also determine equivalent circuit parameters also. Hence the regulation at any load and any power factor can also be predetermined. Like in the case of OC and SC test, here also we can calculate regulation and efficiency for any loading condition and for any power factor condition. Along with that, we can also calculate equivalent circuit parameters, like that is R0, X0, I0, IC, IM, R1E, X1E, Z1E. Everything we can calculate. Then along with that, the results are accurate, because here it will be taking into account all the heating information. Right. Then the only limitation is that two identical transformers are required. It means that the drawback, what we can say here is that This test requires two single KVA rating transformers. That is the limitation. In practice, exact identical transformers cannot be obtained as two transformers are required. The test is not economical. So here, although we are getting exact values of the efficiency and regulation, but getting two single KVA, getting two single transformers is a limitation. Limitation, and also it requires two transformers, which is not economical. So this is all about Sumpner's test, which is an important question which will be asked in your video exam.